today we're graphing sine and cosine functions. The goal, you guys will be able to graph transformations of sine and cosine functions. It's going to be divided out into the next few days. So please make sure that you are asking your questions where you need to, doing your necessary prep work in between to make sure that you are successfully able to graph sine and cosine functions with different types of transformations. Now, properties of sine functions. We've graphed this in our problem, right after the problem of the day. So we already talked about what's the domain of the sine function. Negative infinity to positive infinity. Only two people answered that one. That's very interesting. What's the range?
1 to negative 1 to 1. With brackets.
It does have brackets, but which number are we putting first?
Negative 1.
Because we're reading like on a number line. Negative 1 comes before positive 1. Brackets, they're included. There is a y-intercept. What's the y-intercept of your sine function? 0, 0. We do have an x-intercept at 0, 0, but we also have x-intercepts where else? Where else? At pi, negative pi, 2 pi, negative 2 pi, and actually we have a few more after those, such as, what do you think the next one's going to be? This one's going to be 1 at 4 pi, 5 pi, 3 pi, 6 pi, 7 pi, 8 pi, negative 3 pi, negative 4 pi, negative 5 pi, because it's going to continue, right? Because the domain is negative infinity to infinity, so at every single pi, you're going to have an x-intercept.
You just put pi at every single y.
No.
Every single pi.
And you can't say every single pi. How could I write every single?
Oh.
Can you do that?
Can you put pi infinity?
And
Yeah. Who said it?
Oh.
N pi. Where n
Genius.
is what type of number? Not all real numbers. Not whole numbers.
It can't be a fraction numbers.
Integers.
Integers. I saw someone said on that side.
D.
Integers, which are your positive whole numbers and your negative whole numbers. Okay? So in pi, that's where your x-intercepts occur. At every single pi. Is it continuous?
Yes.
Yes. From where to where? And we talked about its symmetry. What type of symmetry does it have? Which means it's what type of a function? Extrema. What did extrema mean? Max and mins. We do have maxes and we do have mins. Okay?
We have 1 pi over 2.
There are a lot of maxes and there are a lot of mins.
So do we put the weird little thing we did for x-intercepts too, because it's never ending, so it's always going to happen at the like halves?
Yeah, it's always gonna happen.
Because if it gets first half between pi, and then half between pi and 2 pi, which means between 2 and pi.
Negative pi over 2 is a half. So that's
You gotta be careful. We do have a max here, pi over 2. We know that. What we can't say is at every half pi because there are different things happening at every half pi.
So it'd be at every other.
It's gonna be a rough. It's not gonna have an absolute maximum. It's gonna have
It's only relative. Where would the next maximum occur if I were to keep going?
the next pi over 2,
Which is what? 5 pi over 2. Okay? And it's going to continue that way. How far apart are these maximums?
2 pi. 2 pi.
2 pi.
2 pi. Because pi over 2 to 5 pi over 2, if you subtract them, that's 4 pi over 2 for a total of 2 pi. So every maximum is going to occur every 2 pi. So how do you write that?
With special powers.
You start with one of your maximums. It could be any maximum. So you could start with negative 3 pi over 2 plus 2 in pi.
Teachers, pardon this interruption. We need the
So this is how you would represent all the maximums of your sine function. Okay? Because if you start at pi over 2 and then you continuously add 2 pi, you would end up at another maximum. Your minimums. What's one of your minimums? negative pi over 2. You could have also put 3 pi over 2. And how far are the minimums from each other? So it's going to be another plus 2 in pi. Because if you look here, these minimums are 2 pi units away from each other. So those are your extrema, your maxes and your mins. Questions on that? Yes?
Will it always be that?
Will it always be that for your sine function? Yes.
Just sine.
Now once we translate it, it
Yeah.
changes.
Right. I'm just making sure.
What about in behavior? What's happening is x gets closer and closer and closer to infinity. Yes? Equals infinity?
But it can't go to one or negative one.
It can't go to 1 or negative 1 because it has to approach a specific number. It's either going to be,
I mean, it can, but it
it can't go past negative 1. It can't go past positive 1. Honestly, it's just bouncing back and forth between positive 1 and negative 1, isn't it?
Yeah.
So it's never really actually approaching one number, right?
It's just.
So when that happens, your in behavior, what do you think that stands for? Does not exist.
So,
It's like
but
one.
would you put, like,
You put like the location, you just go with one.
So you actually, you right, does not exist.
How does
Okay.
it, how does it not, you said we'll follow, it would just have to follow as if it approaches negative and positive and following, so.
Because the bigger that x gets, your y's are never approaching one number. They're either going to get closer to 1 or closer to negative 1, closer to 1, closer to negative 1 as it goes along the curve.
They're never getting close to one specific number.
It's
Like,
never getting close to
it's
one
like-
specific number.
now-
It's just oscillating in between two numbers, and it can't do that. In behavior cannot do this. It's either going to approach one solid number
and keep going?
and keep going, or it's going to approach infinity, keep on getting bigger and bigger. It can't oscillate in between two values. Yes.
Did the oscillation ever stop and give yourself an behavior?
Yes, but that's for dampen, trig functions, harmonic motion, things like that. But that's for another class.
Hey, this guy.
Is that because it's continuous? 'Cause, like, if it was an infinite discontinuity, then it would follow it?
Exactly. Questions? All right. Let's look at cosine.
Yeah.
We talked about cosine. What's the domain?
Infinity.
Negative infinity to infinity. What's the range?
Same thing.
Two.
It's negative 1 to
Brackets or parentheses?
brackets.
I have a y-intercept where?
1, 0.
Yes.
Careful.
0, 1.
0, 1.
Oh, yeah.
And I have x-intercepts
Everywhere.
everywhere.
Negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and that. No, it's every pi, not 2 pi.
So it's every pi,
So it'd be pi over 2 plus n pi.
pi over 2 plus n pi, where n is what?
1.
Integer.
It's not
Integers. So if I were to plug in 3, n for n, that would be pi over 2 plus 3 pi. Alright, if I were to get a common denominator, that would mean that at 7 pi over 2, I would have an x-intercept. And if I were to keep going,
You would.
you would, because the next x-intercept would occur at 5 pi over 2, then the next one would be 3 pi, and then again 7 pi. Is it continuous?
Yeah.
What's the interval is continuous?
But it's not because it's an behavior.
Symmetry is
Exactly.
the y-axis.
Symmetry is y-axis, which means what type of function is it?
Even.
Even. Julie's already told us that our end behavior is not going to exist, because it's going to do what?
Oscillate.
It's going to oscillate in between negative 1 and 1. And my extrema,
Let's see, the max would be at 1, 0,
I got a max at 0,
1.
and where else?
2 pi.
2 pi, and where else?
Negative 2 pi.
And using a little bit of inductive reasoning, where will my next max occur?
4 pi. 3 pi, 3 pi. Negative 4 pi.
Negative 4 pi
4 pi.
and 4 pi.
So it's the same thing as the other one.
So it's every 2 pi. I need a starting point, so that's why you put the 0 plus 2 and pi. You could have put 2 pi, you could have put negative 2 pi, but you just need a max to start out with. You just couldn't say
It's every 2 pi.
it was starting point.
So you can never just state it's never every 2 pi. You always say that's where we start from.
It's always good to have that as a reference, especially if you are dealing with any that are being transformed, moved left or right or anything like that. What about your mins? Where are they happening?
Every 2 pi.
Every 2 pi's, I need a starting point.
Pi, negative pi.
I can say negative pi or positive pi. And in both situations, n is an integer. And these are your properties of sine and cosine, okay? Are there any questions? If I ask you to give me all of the minimums of your cosine function, just regular cosine x, what would you tell me? Pi plus 2 and pi. That's what you would give me if I want you to give me all of the minimums of your cosine function.
Well, if you ask for that one specific one, would be
We'll
put.
just plug it in for everything.
You could give me pi, you could give me
Okay. So if you
5 pi, you could give me
so if you were just like, give me 1 or 2 minimums of cosine, we just say like pi.
negative pi.
Okay. And same thing for sine or whatever.
Now both sine and cosine functions are known as sinusoidal functions because they both have the shape of the sine curve. And these two are your general forms for your sine function and your cosine function. Now realize those A, B, C, and D all represent some numbers that deal with transforming your original sine function and your original cosine function. We've talked about all the different types of transformations that there are back in unit 1, I believe.
Question, would this equation change it to the other like types of transformations?
I think I follow.
I just
What-
stated
like,
form and.
like if we were to use this, what would this change our graph to? What would this be changing? Make it look like?
So this would be changing your original sine y equals sine x function. So A affects the original sine function in a certain way. B affects it in another way. C another way. D
So
another way.
each one of those numbers affects the graph one on a certain way.
The one that you guys graphed in your problem of the day.
It's the same
Well,
thing
what
with the
does
stretches
baby
and all that.
Mhm.
The outside on the left is stretches and the inside's moving.
Yep, and we've done this before.
Yeah.
All of these we've done.
What is A, B, C, X?
Numbers.
They all A, B, C, and D all represent some numbers
And what is it?
that affect the way the graph looks. Now we've talked about this a long time ago, okay?
Yes, so
If you have your x squared function, okay,
the letter
and then you had x minus 2 squared, what did that minus 2 do to that quadratic function? What did it do?
it moved it right to.
Moved it right to, okay? The same thing applies with your trig functions.
So that means A.
What did this 3 do?
Up.
Moved it up 3. So it does the same thing with your trig functions. What,
The 3 makes it skinnier or stretch.
And then the negative 2 makes it go
Right.
right to.
what type of stretching does this 3 do?
Well, I can't remember.
It was a vertical stretch. Compared to the one that was on the inside would be what? Horizontal, and it was always, whenever it was in the inside, it was always the opposite, okay? So if you had 2x
It was
squared, it would be horizontal stretch by what? 1/2. The same types of transformations do apply to your trig functions, sine and cosine, okay? So to refresh your memory, for those who don't remember, when you're adding on the outside of the original function, remember f of x represents your original function, you're going up, subtracting, you're going down. If it's on the inside, you're moving left or you're moving right. If there's a negative on the outside of your function, you're reflecting it over your x-axis. If the negative's on the inside, you're reflecting over your y. And then of course, do not forget your vertical and horizontal stretches. Again, these same transformations can be applied to trigonometric functions. What is happening to sine x here in the g function? What is happening?
horizontal stretch.
Careful. It's a vertical stretch.
It's horizontal when it's inside the parentheses.
It's horizontal when it's inside the parentheses. If there are no parentheses, then it can't be horizontal, okay? So it's a vertical
By 1/4.
by 1/4.
He doesn't have.
Not really a stretch, but more of a compression. So it shrink. So basically it's getting closer and closer and closer to the x-axis. What about B? What's happening to the cosine function?
Vertical.
It's a vertical what?
Stretch.
Stretch.
It's also rough. No.
Well, vertical stretch by what? By 3. Because what does the negative do? Reflects it
Over X.
over the x. Okay? Anytime there's a negative, that means it's getting flipped. You can't have a vertical stretch by a negative no. Only stretches only positive numbers. I want you to do C, D, and E. Do C, D, and E. Alright, so C, horizontal what? Stretch by 3. Remember, it's always the reciprocal. This is the same thing as saying 1/3 x. That's the same thing. Over here, it's reflected over the y-axis. You make it on your x is negative, and up 3. In this last one, you're moving left 1 and down 2. Okay, so your homework tonight is going to be dealing with describing these different types of transformations. Please make sure that you are doing your prep work and staying on top of each of these lessons.